Welcome back, ladies and gentlemen. Today we're talking about finding the area of a trapezoid when it's on a grid. So some places you might see this are going to be like Google Maps or a layout. Well, let's just face it, mostly maps. You can actually lay a grid over anything. So if you're designing something that you're going to build later in the future to be able to get the correct dimensions, engineers typically put those over some kind of grid. So we can use this idea of a grid to be able to find the area of something if we don't know its measure. What we do know is this length is 1, this length is 1. And to be honest, that's all we need to know. What we're looking for as far as a trapezoid, we're looking to fill in the area of a trapezoid is going to be the base 1 plus base 2 divided by 2, all multiplied by our height. So we got to be able to figure out what our base 1 is. We got to figure out what our base 2 is, and we have to figure out what our height is. So we have to go back to our definitions to decide what is base 1, what is base 2, or really what just a base is. And we have to remember that our base are the two parallel sides. In this case, it's 2. It's not always 2, but in this case, since it has 2, they have to be parallel. So both of these are bases. So this is base 1. Why? Because I chose it to be. Base 2, why? Again, this base 1's already taken. That's base 2. I can count this up. 1, 2 for base 1, and 1 unit for base 2. Now I got to figure out my height. Well, the height is the distance between base 1 and base 2 given the line that is perpendicular to both, or cuts through both at a 90-degree angle. So 1, 2, 3, 4, 5, 6. This goes through at a 90-degree angle here. It goes through at a 90-degree angle here, and it's 6 units long. So that ends up being my height. So my height is 6. So we're going to take that and we're going to substitute it into our formula. So the area of this trapezoid. Oh, I can't draw today. There we go. Notice how I do try to use the drawing here to describe I try to use the picture in describing the area of what I'm doing. Since we talk about area of multiple figures, multiple shapes, multiple anything, using a picture to describe which one we're talking about, it helps. You don't have to do it. You can easily just be writing A equals, and this is fine. I like to do this to be able to keep it straight with me. It's just a practice I have, and it's a practice I will keep. Now, all I got to do is substitute in. So I look for B1, and I find that's 2. I look for B2, and I find that's 1. So 2 plus 1 divided by 2. And then I'm going to multiply everything by 6. So let's go through and let's solve it. 2 plus 1 is 3. Then I'm keeping the divide by 2 and the multiply by 6. Here, I can do 3 divided by 2, or I can realize it's the same thing as 3 over 2 times 6 over 1. And because this is now a numerator and this is a denominator, the like factors cancel, and that's going to leave me with 3. So my problem actually is 3 times 3 over 1 times 1, because 1 is left down here, 3 is down here, because 2 canceled 6 3 times. So I have 1 times 1. Well, anything over 1 is itself, so we have 3 times 3, which is 9, over 1, or 9. Then all I got to do is look up here and look for the number 9. Nope, not it. Not it. Here we go. Here's 9 units squared. On the last video, you might have noticed my mistake that I'm just thinking of now. It should have been meters squared, not just meters. So make sure that anytime you're dealing with area, you do square, and don't make the same mistake I did. Do square your units, whether it's feet, meters, even if it's just the word units. Make sure you take some notes, come in, ask any questions you got, work on those problems for 7.3.3, or sorry, this is 7.1.3. And again, you can work on that tonight or tomorrow. And always remember, it's about the understanding and it's about the process. It's never about the answer. We'll see you tomorrow.